How do forces affect motion? What is motion? Imagine a snail crawling slowly across a patio or a cheetah speeding through the African grassland at 113 kilometers, 70 miles per hour. Picture a snowflake drifting down through the chilly winter air or a comet zooming through space. What do the snail, the cheetah, the snowflake, and the comet all have in common? They are all objects in motion. Motion is a change in an object's position. Almost everything that exists is in motion, from tiny atoms to giant galaxies. As snowflakes fall, moving air pushes them all around. That is motion. How do you describe motion? You can describe motion by its velocity. Velocity is made up of two things, speed and direction. Velocity is not the same thing as speed. If you say the cheetah was running at 100 kilometers per hour, you are talking only about speed. But if you say the cheetah was running north at 100 kilometers per hour, you are describing velocity. If the cheetah turns suddenly and heads northeast at the same speed, it has changed its velocity. If the cheetah keeps heading straight north but slows down, it has also changed its velocity. The velocity of an object does not change, its velocity is constant. A car on this curvy road could not have a constant velocity. The car would have to change direction because of the curves. What makes objects move? An object moves when a force acts on it. A force is a push or pull that can cause a change in an object's motion. A push moves an object away from the source of the force, and a pull moves the object toward the source of the force. Any change in an object's motion is caused by force. A force can make an object start moving or speed up. A force can cause an object to slow down or even stop moving. A force can make an object change direction. A force can even change an object's shape, as when you bend a straw or squeeze a ball of soft clay. The people pushing the car are moving the car away from them. They are applying a pushing force. How can you make objects move faster and farther? How far can an object move? It depends on the strength of the force moving the object. The greater the force, the farther the object moves. With a friend, do this experiment. Choose a spot on a soccer field. From there, kick a ball twice. First, use your stronger foot. Then, use your weaker foot. Have your friend measure how far the ball went each time. Which foot kicked the ball farther? It is the same ball, so its mass did not change. But your stronger foot put more force on the ball, so the ball went farther. Not only did the ball go farther, but it also went faster when you kicked it with your stronger foot. To make the same object move farther or faster, use more force. The kicker's foot makes a push force. This force moves the ball up and forward. What if you apply the same force to objects that have different masses? Well, the answer is that the object with a smaller mass will go farther. Imagine that you have a junior soccer ball and an adult soccer ball. You give the junior ball your best kick, and then you give the adult ball your best kick with the same foot. You'll see that the junior ball went farther. It also went faster. This shows that the same force will move a smaller mass farther than a larger mass. If you want to try this yourself, you probably won't be able to kick the exact same force every time. But try kicking each ball 3 times, then figure out the average distance traveled by both balls. The smaller ball has less mass than the bigger ball. The smaller ball will go farther and faster when kicked with the same amount of force. How do you make objects change direction? When only one force is applied to an object, motion goes straight in one direction. What happens if you apply a second force? If you apply a second force from a different direction, a moving object will change direction. For example, suppose an archer shoots an arrow at a target. Then a gust of wind blows the arrow off target. Wind is a second force. It changed the direction of the arrow. A force can change an object's direction even when the object applying the force isn't moving. A rolling pool ball changes direction when it hits the side of the pool table. The table didn't move, but it applies a second force that is a pushing force. At the point where the ball hits the cushion on the edge of the table, the cushion exerts a push on the ball. This force changes the ball's direction. How can an object exert a force without moving? Think about this. If you lean back far enough, you would fall over. But when you lean against a wall, you don't fall down. Why not? Well, it is because the wall exerts a pushing force against your body. It holds you up. Here's another example. Suppose you push down on your desk. Why doesn't the desk just collapse? Well, it is because the desk has a force that pushes upward. The desk doesn't move, of course, but its upward push is stronger than your downward push. If you had super strength, you could push downward with a force that is greater than the force of the desk. Then you would crush the desk. These desks don't seem to be exerting any force, but they are. What is gravity? When you jump on a trampoline, you go upward. Why don't you just float away? Why do you come back down? Well, you come back down and stay down because of gravity. Gravity is the force that pulls objects together. It is called a force of attraction. Gravity acts on objects that are touching, but it also acts on objects that are not touching. That is unusual. Why? Well, remember that you have to touch an object in order to pull or push it. Even the wind has to touch an object in order to move it. But gravity does not have to touch an object in order to act on it. Scientists understand what gravity does, but they still don't understand how. An upward force is necessary to get off the ground. A bird uses a strong upward force to take off in flight. Gravity exists between any two objects, but the force of gravity is not the same for all objects. The amount of gravity that pulls two objects toward each other depends on two things. It depends on the mass of each object and the distance between the objects. More massive objects put forth more gravity than less massive objects do. Earth has more mass than the moon, so Earth has stronger gravity. On Earth, you might be able to jump about 1/2 meter high. On the moon, you would be able to jump much higher. Gravity is weaker when there is more distance between two objects. For example, Earth is millions of kilometers away from the sun. At this distance, the sun's gravity keeps Earth in a steady orbit. But the sun's gravity is not strong enough to pull us too close to the sun. The sun's gravity keeps the planets in orbit even though they are millions and even billions of kilometers away from the sun. What does friction do? Friction is a force that opposes or works against motion. Friction is made when two objects touch. If one of the objects moves, the other object makes friction on it. The friction slows down the first object. When the friction is great enough, the moving object stops. That explains why when you roll a marble on the floor, the marble eventually comes to a stop. It won't roll on forever, even on very smooth floors. Rough objects make more friction than smooth objects do. A rough floor makes more friction on the sole of your foot than a smooth floor does. That is why you can slide in your socks on a smooth floor, and you can't slide on a rough floor. The smooth wheels of the skates let the skaters glide easily across the smooth, polished floor. Sometimes friction helps us. Have you ever wondered why car tires have deep treads or grooves? Well, it is because treads help to increase the friction between the tires and the road. This friction keeps a car from sliding off the road. Friction helps the car stop when the driver applies the brakes. Sometimes friction gets in our way. If you ride a racing bicycle, you want smooth tires so that you can go as fast as possible. Too much friction slows you down. Friction also produces heat. The energy of motion turns into heat when two objects move against each other. That is why rubbing your hands together on a cold day warms them up. Deep treads help create useful friction between a car's tires and the road. When do objects stand still? Have you ever seen someone ride a unicycle? A unicycle is like a bicycle, but with only one wheel. Sometimes a unicycle rider can make her unicycle stand still without falling. It seems like magic, but it's not. It is simply the laws of physics. When the unicycle is still, all the forces acting on it are equal. No force is stronger than the other forces, so the unicycle does not move. When forces acting on the same object are equal in strength and opposite in direction, they are called balanced forces. Objects remain still when the forces that are acting on them are all balanced. The rider makes tiny movements to balance the forces acting on the unicycle. That keeps her from falling. Forces must act on the same object in order to be balanced. For example, suppose you are reading a book. Earth's gravity is pulling the book downward. Your hands are pushing the book up. You use just enough push to balance the pull of gravity. That is an example of balanced forces. Now look at two other forces in the same situation. The book is pushing down on your hands. Your hands are pushing up on the book. Those are considered balanced forces also. To hold up a book to read, you use force against the pull of gravity. These are balanced forces. What makes an object start moving? When objects stand still, when the forces acting on it are balanced. When does an object start to move? Well, an object begins to move when the forces on it go out of balance. When one force is stronger than the other force acting on the same object, the forces are called unbalanced forces. For example, imagine the ball in a pinball machine. The ball sits still in a slot. The forces on the ball are balanced. Then you flip the lever. The ball shoots forward. Then friction acts on the ball. Friction slows the ball as it rolls upward. Then gravity makes the ball roll back down. Next, the ball hits a post and changes direction. Then the ball hits a side and changes direction again. Unbalanced forces cause every change in the ball's speed or direction. Unbalanced forces make the ball in a pinball machine change speed and direction. What if an object is moving but not changing speed or direction? Its forces are balanced. This happens when a rocket flies through outer space. When the rocket lifts off, it needs a huge force of its engines to escape Earth's atmosphere. Once the rocket is in space, though, the engines shut off, and with no forces to slow it down, the rocket keeps going at the same speed. The strength and direction of forces are shown by arrows. The longer the arrows, the stronger the